Time delay. There are two ways to create a time delay in 8051 microcontroller. That is one way that we can use the software delay, and the second one is using the timers. So we know that when we study the architecture of 8051, we study there are two 16-bit timers for 8051 microcontroller. We can use this timers to generate the time delay, or else we can use software time delay. But in the case of accuracy, the software time delay is not accurate. So for more time definite cases, we use hardware time delay. That is by using the delay is generated using the timers. So the software time delay that depends that will be vary from different manufacturers, 8051 manufacturers. So it depends on the 8051 design, that is the number of cycles. So initially the 8051 a machine cycle consists of 12 clock cycles. So number of it depends on the number of machine cycles and number of clock periods per machine cycle. And the other one is that the crystal frequency, that is it depends also, software delay also depends on the crystal frequency that is connected to the crystal pin. The crystal input pin, we know that an 8051 microcontroller has the XL1 and XL2 input pins. So a crystal oscillator will be connected to this particular pin, and the frequency of this crystal oscillator depends on the clock period of the microcontroller. And the compiler choice. So different compiler, when we use C compiler in assembly language, we get more accurate delay. But when we are using a C program to generate the delay, the C different compiler, when the C code is converted to assembly language, the delay may change. So different compiler produces different codes, different delay, time delay. Write an 8051 C program to toggle bits of P1 continuously forever with some delay. So here it's the delay is unknown, but what we want to do is the toggle the bits of P1 continuously. P1 means it's a port 1. So we include the header file, void main, unsigned character S, and integer S, and for our loop. Here the port 1, first we sent 555 hex, that is 0101 0101, and after a time delay, here an unknown delay, here we have given a 40,000. The 40,000 times the for loop executes, it generates some delay, and after that we have sent 10101010 to port 1. So it toggles, and also again we generates a delay. So to calculate the delay that is generated by this, we use an oscilloscope to the excite measurement. So here first we sent 01010101, and after a delay we sent 10101010. So the 8 pins of the port 1 gets toggled in a delay. Let's write an 8051 program to toggle bits of port 1 continuously with 250 milliseconds. So here the delay is given. So in this case we are using another subroutine, that is another function, that is ms delay function, unsigned integer. So what is the delay that you want to generate can be sent as an argument here. So while 1, that is for repeat for our loop. First we sending 55 hex to port 1, then we are calling the delay ms delay 250. So it calls this function, and here the 250 value that is sent here, the sent as an argument, name itime. So here this itime, this is here it comes the 250. The itime is the variable name that is given to this argument. So 250 times this loop executes, and here it is designed as here this loop is placed 1 to 75, that means it is designed as it generates a one when it executes one time, time value when it executes one time, it generates a 1 millisecond delay. So when it executes 250 times, it generates a 250 millisecond delay. This is the value that is calculated for that. And LEDs are connected to bite-sized. The next is input-output programming. Bite-sized input-output. That means we are outputting 8 bits at the same time. That is bite-sized input-output. So LEDs are connected to ports P1 and P2. So we know that port 1 and port 2, it contains 8 bits. So 8 LEDs will be connected to port 1 and 8 LEDs will be connected to port 2. Write an 8051C program that shows the count from 0 to FF. 00 to FF. There is a count that we need to generate in the LEDs. So LED here include the register file. Define LED P2. So the name of port 1 we are defined as LED. So wherever we represent LED, that means we are representing port 2. Define keyword is used to name the port 2 as LED. So port 0 to port 3 are byte addressable, and we use P0, P3 labels as defined in 8051 or 8052 header files. So 8051, here we can give another name P2. If we are using this header file, Fetch 51 header file, we can just give the name P2. If you are not using the header file, you need to represent the address. You need to give the special function register address. P2 is a special. All the ports are special function registers, port registers. So you need to specify the address of the port register. If we are not using the register, the header file. If you are using the header file, you can just represent P2 to represent the port 2 and P1 to represent port 1. So here we are giving a name to port 2 alone, that is port 2 as LED. P1 and main, the first we are sending clearing port 2 and LED equal to 0 means first clearing port 1 and LED equal to 0 means we are clearing port 2, because the name LED name is given to port 2. Wherever we represent LED, that represents the port 2 itself. And repeat for our loop. We increment the port 1. That means the port 1 initial value is 000 hex, and when we increment, the value becomes 00000001. And LED is also incremented, that is port 2 is also incremented. Port 2 also displays the same value. So this for our loop executes repeatedly, then we will get the value 00 to FF. Write an 8051 program to get a byte of data from port 1 and waits a half second and then send it to port 2. So you need to get a data from port 1. So port 1 should be declared as an input port. So we are using unsigned character my bit to get the data. We need to place the data from port 1 to my bit, and then after a delay we are outing to port 2. So my bit is used to get the data, and port 1 is equal to 0xFF. 0xFF means we are declaring the port 1 as the input port. By default it will be as output port. When you declare with high value, there is 0xFF, it works as port input port. And for our loop, we get the value from port 1 to my bit variable, and after calling for a delay of 500 milliseconds, and then outing to port 2. P2 is equal to my bit. The data from port 1 is out to port 2. It's referred to get a byte of data from port 0, and if it is less than 100, send it to port 1, otherwise send to port 2. So here we need to get data from port 0. So port 0 should be declared as input port, and we are checking here, we get the data and we are checking the condition, that is if the data is less than 100. So when the data is less than 100, send to port 1. So if it is less than 100, we are outing the my byte to port 1, else we are outing my byte to port 2. A bit addressable. So now we have seen the byte addressable ports. Next is bit addressable. 805 write an 8051 C program to toggle only bit P2.4. So far we did all the bits are altered, so continuously without disturbing the rest of the bits. So we need to access only one bit, that is P2.4. So S bit is the keyword that is used to represent a particular bit. So S bit, my bit, is equal to P2.4. Here the P2 raised to 4 means the port to 4th bit. 4th to 4th bit is named as my bit. So my bit is first turned 1, then turned 0. No other bits are altered, only this P2.4 is altered. This, when outing 1, that is turning on P2.4, and outing 0 turns off P2.0. So write an 8051 program to monitor P1.5. If it is high, send 55 to port 0, otherwise send AA to port 2. So we need to monitor this P1.5. So P1.5 should be declared as an input port. First we are naming it as bit, my bit P1.5. So my bit is the name given to P1.5. So my bit is equal to 1. That means it is declared as an input port. Make my bit port P1.5 as input pin. We are giving it a 1. For our loop, we are checking the condition. If it is high, send 55 to port 0. So if it is high, port 0 is equal to 55, and else we are sending AA to port 2. A door sensor is connected to P1.1 pin and a buzzer is connected to P1.7. So write as a program to monitor the door sensor, and when it opens, sound the buzzer. We can sound the buzzer by sending a square wave of a few hundred hertz. So here we are using 2 pins, that is P1.1 and P1.7. So P1.1 is an input. It's input from a sensor, so it should be declared as an input. We are giving the name P1.1 a door sensor and P1.7 a buzzer. So door sensor equal to 1, that means making P1.1 as an input. While door sensor is equal to 1, that is the door opens. Buzzer, first we are sending a 0, then after a delay it turns 1. So you will get a pulse signal. That's a square wave is generated here. So the buzzer will sound. The data pins of an LCD are connected to P1, that is to port 1, and the information is latched into the LCD when it is enabled goes high to low. Write an information, the earth is but one country. The earth is but one country to LCD. So we need an enable pin. The enable pin is connected to P2.0. So the name it as P2.0 is named as enable. Here LCD data declaration is done. Hash define LCD data P1. So LCD P1 is declared as LCD data pin, and P2.2 for enable. And unsigned character, the message is given in an array. The earth is but one country. send character is that here we have 28 characters, that is we need to